Welcome, engineering students. My name is Mr. C. Tobejane from Ehlanzeni TVET College, Mlumati campus. Today we'll be looking at engineering science under the Department of Engineering at large, mechanical engineering, as well as electrical engineering. So we'll be looking at the topic friction in particular. As we know that engineering science, N3 engineering science is broad. It consists of exactly 8 chapters. But today, we are not going to be looking at all these chapters, but for now, we'll look only on the part of friction. The first most important thing that we need to know is to understand what is friction and how does friction occur. Now, it is said that when two surfaces are in contact, when these two surfaces are in contact, and then there is movement which tends to take place in these two surfaces, friction occurs. Now, that force which occurs in these surfaces is called the force of friction, or in simple terms, the frictional force. Now, as we know that any object that is placed on a horizontal surface, that particular object is affected by mainly 4 forces. As we can see on the screen, the forces are labeled there. We have the first force, which is the applied force. Remember, the applied force, this is that force which is required for the object to move from one place to the next place. And then there is frictional force. Frictional force needs at all times to be less than the applied force for the object to move. Now, if we have a scenario where the frictional force is greater than the applied force, then unfortunately our object will not be in motion. We have the weight of the object, W, is equal to mg, m being the mass of that particular object, g being the gravitational acceleration. In this case, as we know, gravity is always acting vertically downwards, and it's a constant value, 9.8 meters per second squared. So for us to find the weight of this particular object, we need to multiply the mass by the gravitational acceleration. We also have our normal reaction. The normal reaction, since this object is placed on a horizontal surface, this means that the normal reaction, or rather the reaction force that acts upon that particular object, will be equal to the weight of that object. So in all cases, in all objects which are placed in a horizontal surface and these objects are expected to move, these objects will be affected by such forces. Now, with regards to friction, these are the equations that we normally use, more particularly on horizontal surfaces. The first equation there is the frictional force, F mu is equal to mu multiplied by the normal reaction. That mu is actually a coefficient of friction. So for you to calculate your frictional force, F friction is equal to coefficient of friction multiplied by normal reaction. The weight, we've already seen it. Weight is equal to mg, and the applied force is equal to ma. Now in this case, A is the horizontal acceleration of that particular object. Remember, acceleration is the rate at which velocity is changed, or the rate of change of velocity. So when this object is sliding on a horizontal surface, this object will be sliding at a certain acceleration. We have theta, which is the angle of repose, or the angle of friction. The angle of friction is calculated by tan inverse of mu, or rather tan inverse of coefficient of friction. And then the coefficient of friction itself is calculated by the frictional force divided by the normal reaction. Now, we've already explained that the normal reaction is equal to the weight, which means that the frictional force will be equal to a coefficient of friction multiplied by mass multiplied by a gravitational acceleration. Now, before we can go to any calculations whatsoever, let us understand let us have a deep understanding of friction. First, let us look at the uses of friction, or rather, the advantages of friction. Now, the resisting friction is essential for these parts which are named there or listed. for tires to grip on road surfaces if you are moving with a vehicle, so that that vehicle will not slip away from the surface, we need friction for it to stay constant in that particular road surface. For a grip in belt drives, example in vehicle engine, we have what we call a fan belt. For that fan belt to operate without any slippery, friction should be there. For brakes to work, if you apply brakes in your vehicle, for that vehicle to come to rest or to slow down, friction must be there. For gripping clutch in vehicle, for those who use vehicles, manual vehicles, they know that when you press on your clutch, it needs to operate, and for it to operate, friction should be there. And lastly, for nails to grip on wood, if maybe you are working with wood. And then again, we also have the adverse effects of friction, or rather the disadvantages of friction. Listed here, they are not limited, but I've only listed a few. Now, when this vehicle is moving on a road surface, the tires will wear away. That is the effect, that is the biggest disadvantage of friction. When you apply your brakes, the tires are wearing away. The wearing away of piston rings and cylinders in large machineries. There we use piston rings and cylinders for these machines to work. So because of friction, they are at risk of wearing away, as well as wearing away of bearing and linkages. Now, these are the effects of friction. But again, friction is a very nice thing because we mostly use friction in a lot of things. It is very important that we have friction. This means that friction on its own, it has its own laws. These are the laws of friction. This will state, or rather will indicate, whether friction depends on any surface, mass of an object, surface area, or the pressure of that particular object. The first law of friction states that friction is proportional to the normal pressure between the two surfaces which are in contact. What does this mean? If an object possesses greater mass, it means that the pressure that it suppresses on the ground is more. So the bigger the pressure, the bigger the friction. If this object is lighter, then we are going to have less friction because the pressure which is suppressed on the ground is less. Friction depends on the nature of the surface in contact. This means that if we have a smooth surface, we're going to have less friction. If we have a rough surface, then we are going to have greater friction. But again, friction is independent of the area of contact. It doesn't matter how much area that particular object is occupying in that surface area or in that particular environment, as long as that object is in contact with a certain surface, friction will be there. Friction again is also independent of the speed. The speed with which the object moves doesn't really mean the faster the vehicle, the greater the friction, or the slower the vehicle, the lesser the friction. So friction doesn't depend on the speed, it doesn't depend on the area of contact, but friction depends on the surface area, the nature of the surface area. Again, friction depends on the normal pressure which is present there. Now, since we've spoken about friction, and I believe that you understand now what is it that is friction and where do we find friction, the advantages of friction, the disadvantages of friction and all that. Let us calculate now. Let us try to put friction into practice to find the exact values that you obtain in a certain scenario. We have an example. A cardboard box of books which has a mass of 70 kg requires a horizontal force of 180 Newton to drag it at a constant speed across a wooden floor. For you to calculate this, we must go back to the nature of this cardboard box which is placed on a horizontal plane. Now, remember, we said this cardboard box or whatever object which is placed on a horizontal plane will be affected by four forces. which is the normal reaction, the weight, the frictional force, as well as the applied force. But now we need to take our values as given there and apply them here. What are we given? We are given the mass of this particular cardboard box. The mass is 70 kg. With this 70 kg, we need to find the weight of this object. How do we find the weight? We need to substitute it here. It means that weight will be equal to 70 multiplied by 9.8. Now you should be calculating that. You should be punching in your calculator. Gladly, I have my own calculator here. So I can find that 70 multiplied by 9.8. This is 686. 686 Newton. Remember, this weight is equal to the normal reaction. This means that for every value that you find of this weight will be equal to the value of the normal reaction. Now they said again, this weight, this object requires a horizontal force of 180 Newton to drag it at a constant speed across a wooden floor. If they speak of dragging this particular object on a constant velocity, this means that they've given us our frictional force. So here we have our weight, we have our normal reaction, we have our frictional force. But what is it exactly that they are looking for? Now, here are the questions. We are required to calculate the coefficient of friction. Do you remember the equations? We did go through them. But then I've taken the pleasure of listing them. In this case, if you are given a question like this in an exam, the first thing that you need to do is to know what is it that you are given. If you find what is it that you are given, what is it that is required by the question, then you can check your formula, which formula exactly is best suitable for that particular question. In this case, we have 5 formulas and we are required to calculate the coefficient of friction. Which formula can we use there? Right, we can go to the 5th equation, which is coefficient of friction is equal to the frictional force divided by the normal reaction. That is the correct equation that we can use, because provided we do have our frictional force, it's given 180 Newton. We have our normal reaction, which we calculated here. So we can as well just substitute these values here. We have 180 divided by 686. And then if we punch that in a calculator, 180 divided by 686, this should give us 0.2624. That is the value of our coefficient of friction. Now the coefficient of friction will not have SI units. The reason is our frictional force is measured in Newton. Our weight is measured in Newton. These units will then cancel out, and then we will not have units for the coefficient of friction. Now let us move to the next question. They say calculate again the angle of friction. In most cases in a question, they may not say angle of friction, but they may use angle of repose. So angle of repose and angle of friction, these are the same thing. Now, we can pick on our equations there which equation is best suitable to calculate this, right? If I'm checking there, the 4th equation is best suitable to calculate the angle of repose. To calculate the angle of repose. Now, theta is equal to tan inverse of mu, or rather the coefficient of friction. We already have the coefficient of friction there, so we can substitute that value there. Tan inverse of that should give us 14.7 degrees. This is the angle of repose. This is the angle which is found between these two surfaces which are in contact with each other. When the movement takes place, friction goes in an opposite direction, then we find our angle of repose. And then the last question is more interesting. They say here, calculate the horizontal force that will be required if a similar box is placed on top of the first one. Now, we are not given the weight of this object. It is not given in numbers there, but they are saying a similar box is placed on top of the other. What does this mean? It means that originally we had one box which has what? A weight of or a mass of 70 kg. They say a similar box is placed on top of this one. This means that another box similar to this one, means it has the same mass, is placed on top of that particular box. Now they want you to calculate the horizontal force which is required. Now there are two ways of working this thing out. The first method, I will show you. The first method, you can go to your first equation. The first equation, you see the first equation, you are calculating the frictional force. The frictional force is given by coefficient of friction multiplied by normal reaction. And then your coefficient of friction, you already calculated it, 0.2624 into. Remember, how do you calculate your normal reaction? Your normal reaction is calculated by mg. But in this case, we have two boxes. It means we're going to have to add these two masses and have one mass. It means we're going to have 70 plus 70. This should give us 140. Let me just shorten it like that. 140 multiplied by 9.8. You punch that in your calculator, 0.2624 into 140 times 9.8. This should give you 360 Newton. Now this is the horizontal force which is required to drag these two objects. If now we have another object, placed on top of the other. The other method is simple. Look at this, mathematically. If you have 70 kg, and to drag this force, this weight, you need a force of 180 Newton. What happens when this weight is doubled? Now 70 mathematically says that what you do on the left must be done on the right. So multiplied by 2, that is double the weight. This will be equal to 180 Newton multiplied by 2. This should give you 360 Newton. That is one simple method of dealing with that particular problem. This question, I've seen it appearing many times in question papers, so you need to be careful whenever you come across a question like this, more particularly with the last question, because it's tricky for most students. The mistakes that they do, they would want to recalculate the coefficient of friction, of which is very wrong. The coefficient of friction, once you calculate it once, it remains constant. You are going to use the very same value even when the boxes are doubled, they are tripled, or you have 5 boxes. The coefficient of friction will remain the same. Why does the coefficient of friction remain the same? Because the surface area is not changed. Now, let us do another example and see, a different example, and see if we can be able to remember these things so that we can apply them. In this case, you have an electric motor. An electric motor has a mass of 100 kg. This electric motor must be dragged across a workshop floor. Now we are given the coefficient of friction. Remember the first one, we're given the horizontal force which is required to drag this object across a wooden floor. And in this case, we're not given that horizontal force. We're only given the mass and the coefficient of friction. So we need to be able to calculate this. Now, let me quickly erase this so that we can go to that one and see. I'm going to leave my structure as is because we are going to use the same drawing. I'm going to use the same drawing. So they say this electric motor is what? It has a mass of 100 kg. The electric motor has a mass of 100 kg. What do you do when you have your mass? You find your weight. You find your weight. You find your weight when you have your mass, right? I believe this should be 980. Right. You find your weight. Right. So when you found your weight, this weight is equal to what? The normal reaction. What is it that we are given? Do we have the frictional force? No, we don't have the frictional force. But in this case, we are given mu, coefficient of friction. Coefficient of friction is 0.44. Let us go through the statement again. An electric motor which has a mass of 100 kg must be dragged across a workshop floor. If the coefficient of friction between the motor and the floor is 0.44, then we are required to calculate the minimum horizontal force which is required. So it's almost similar to the previous question where they said a similar box is placed on top of the other. But in this case, we don't have that minimum force at all. We need to calculate that minimum force. Which is that minimum force? This is the frictional force. That is the minimum force which is required to drag this particular object across a wooden floor. Let us look at our formulas. Which formula will best suit what we are looking for? Right, it is number 1. The first equation. First equation. Why are we using the first equation? Because we do have the coefficient of friction and we do have the normal reaction. If we have those, then we know we are sorted. We don't have any problem. It's very simple. I've only identified what I'm given and I used what I'm given to identify my equation. Coefficient of friction multiplied by my normal reaction, which is my weight, 980 Newton. Now you go to your calculator, 980 Newton multiplied by 0.44. This should give you 431.2 Newton. Now this is the horizontal force which is required to drag this object across this floor. It's very simple. And then the last one, we did it, the angle of repose. You know you can simply identify your equation there as we did. The fourth one, that is theta is equal to tan inverse of mu, which is tan inverse of 0.44. Punch that in your calculator. That is 0.44. This should give you 23.74. Let me write 75. Let me just convert it to 2 decimal places. But you can always convert to 3 decimal places. However, it's impossible to be reading your instructions in a question paper. Your question paper will state that you can leave your answer to 3 decimal place or 2 decimal place. So it's very much important to read your question paper's instruction. This is basically what happens whenever you are dealing with an object which is placed on a horizontal surface. Now, remember, an object which is placed on a horizontal surface has exactly 4 forces which are circulating around it. We said that the first force is the applied force. The applied force is that force which results in the movement of that object. The second force is the frictional force. Frictional force is that force which opposes the movement of this object. But the frictional force should be less than the applied force for this object to move. We again have the weight. The weight is equal to the normal reaction. The normal reaction is the force, or rather the weight at which this object reacts to gravity. That means you're going to find it by multiplying the mass with your gravitational acceleration. Remember again, whenever your question comes, in most cases, with regards to friction, your question will not say, state the uses of friction. In most cases, it just simply says, state 3 advantages of friction and 3 disadvantages of friction. And again, familiarize yourself with the terminologies that you might encounter whenever you are dealing with a question. Like for an example, when they use the adverse effects of friction, we know these are the disadvantages of friction. And also know the laws of friction. What is friction depending upon? What is friction not depending upon? When will friction occur and when will not friction occur? Right. But then this will bring us to the end of our session. I believe everything was touched successfully and nothing was left behind. In our next session, we're still going to be looking at friction. Now, In this case, we are going to be looking at friction on an inclined plane. Just to give you a simple scenario, when we speak of an inclined plane, this is what happens. This is where you have an object which is placed on an inclined plane, the inclined plane making a certain angle theta. We need to know what this angle is. Remember, for this object to slide, we need to understand how much angle are we having there. And we are also going to be looking at the forces which are affecting this particular object when it's placed on an inclined plane. Now, there are slight differences when it comes to the equation. You need to add few equations so that this object placed on an inclined plane can come into life, it can be calculated and all that, and it deals with an angle in particular rather than a horizontal surface. Now, this is a bit more complex structure, or rather calculation or scenario that we need to understand. So we'll be unpacking it into details on our next lesson. But for now, let us end our lesson here. And if you want to be in touch, please remember you can always go to our website www.ehlanzenicollege.co.za, or you can just be in contact with us on Facebook, Ehlanzeni TVET College, even on Twitter, on YouTube, it's Ehlanzeni TVET College, Twitter @Ehlanzeni TVET. That's it for now. Till we meet.